Hi everyone, welcome to my channel. In today's tutorial, I'll show you how to use ArcGIS Model Builder. Model Builder is a visual programming tool in ArcGIS that allows users to create, automate, and manage geoprocessing workflows without writing code. Model Builder has four main elements: variable, tool, group, and connectors. Variable has two different types. First one is data variable, like DEM, like elevation, or value variable, which is a constant value. For example, a buffer, you want to make a buffer for 100 meters, for example. That 100 is a constant value. Tool has four different tools: iterators, logical tool, there's another two different tools for logical tools. This one is octagon and this is diamond. In octagon one we check like if-else statement, but for this one it's just branching, true or false. And the last one is the standard normal geoprocessing tool. Third one is group. We group some related tools and just to make our layout good. And the last one is connectors, the standard data connectors, environment connectors, precondition, and feedback. For inputs, there are two colors. If it has a gray color, it means it's not ready to run. If it has a dark blue, it means input data is ready to run. If it is a light blue, this is for input value. For the running, during the running the model or after the run, there's no change of color. It stays same. For the tool, however, it has four different colors. The gray one, it means not ready to run. If it has a yellow, it means it is ready to run. If it is red, that means model is running that specific tool at that time. And if it has the fourth one, last one, is the shadow. It means model successfully ran. Iterator is the same as tool, and logical also same. And for the derived data and derived value, it's just same as the input, except after the run it has the shadows. I have prepared an exercise for today's tutorial. Let's take a look at it. Using the provided data, please identify the optimal areas for solar power plant installation within the specified basin boundaries. Note that only eligible sites larger than 10 hectares should be considered. The data we use: elevation in raster format, cities in point shapefile, and basin is the Polygon shapefile. This is the boundary. And here are the criteria. We have four criteria. First one is elevation. Suitable areas are greater than 500 meters and less than or equal to 1000 meters. For the slope, suitable area is less than or equal to 10%. For the third criterion is suitable area is greater than or equal to 135 degree and less than or equal to 225 degree. Distance to settlements criterion, suitable area is greater than or equal to 1 kilometer or 1000 meters. Okay, let's load our input data. Elevation. Cities. And the boundary. This is the basin area. We can create models in ModelBuilder in 3 ways. The first one and easiest one is just click Analysis tab and click ModelBuilder tool. Second one is in the My Project toolbox, just right click New Model. You can create model like this too. And the last one is if you want to create a model in a specific folder, just you have to create a toolbox first, and then within this toolbox you can create model. Let's say I want to create a model within this folder. Just right click that folder, New Toolbox, and right click again, newly created toolbox, new model. Okay, and first criterion is elevation, so we need to use elevation data. Just click and drag it on the canvas, ModelBuilder canvas. And also for this I need a conditional tool, contour. Click left button on your mouse, click and drag it and input conditional raster. Double click on the contour and where value, let's see again, greater than or equal to 500 and less than or equal to 1000. Where is greater than or equal to 500 meters, right? Click another clause. This we are adding in another clause, and again value is less than or equal to 1000 meters, and input true raster value will be 1 for us. Okay, the pixels that a value between 500 and 1000 will have a value 1, and unsuitable areas or false raster is having a value of 0. And we are saving it in our default project geodatabase, and I am giving it a name, Criterion 1. Then click run here. Let's run it. As you see, the model successfully ran, and because it has a shadow here, and click this derived output, right click, add to display so that we can see it. Click map. Here is the one is the red ones, red colored areas has a value of 1, which means suitable areas. The gray ones has 0, means those are unsuitable areas. Okay, let's go back to model. Let's do the second criterion, slope. For this one, first I have to derive slope from elevation, dm. Thus, click slope and drag it. Let's connect it and double click the tool, and we don't need degree, we need percent, right? Because slope, it says that it should have less than or equal to 10% for the suitable area. And the name, slope percent. Click OK. Let's run it. Okay. Right click, add to display. Okay, good. Let me uncheck this. Cities and basin. Now we use conditional tool so that we retrieve the areas that have 10% or less percent slope. Input conditional raster, double click it. Where value is less than or equal to 10. True raster will have a value of 1, false raster will have a value of 0. And let me rename it to Criterion 2. Run it. Right click, add to display. Yes, that's okay. You see, this is the elevation, and the dark color represent lower elevations, so it makes sense, right? Okay. We did second criterion, and third one is aspect. I have to derive aspect from elevation data. So click aspect and drag it. Click connect, double click it. Just name it aspect. Okay, I don't need to run it right now. I just need this contour because the suitable area will have a value of greater than or equal to 135 and less than or equal to 225. Drag contour, double click, value is greater than or equal to 135, add another clause, and value is less than or equal to 225. Right? 225. Okay. True raster will have a value 1, false raster will have a value of 0. And then let's rename it Criterion 3. Let's run it. You see the red color is running contour right now. And right click, add to display. Okay, this is the criteria 3. These are the because for power plant, solar power plant, we need south facing slopes, right? That's why we are using these values. Okay, the last one is the distance to settlements. At least 1 kilometer distance is recommended due to noise, visual impact, and safety reasons. For this one, I have to create. Let's go back to ModelBuilder. I have to create a distance layer. Euclidean distance tool. I have to use this. And the distance will have a 1000 meters at least, right, from city center. So thus I need these cities. Click and let's connect. Double click. And here output cell size will have same as the elevation, and the most important is the click environment section here, environments, because we are creating a brand new raster layer which is distance, so it should have the same coordinate system with the current map, right? And the extent should have same extent with the elevation. And cell size should be same as elevation again. And let's mask it with the elevation, because I'm going to cut it using the extract by mask using the basin or boundary layer later. Okay, at the moment just click elevation, and snap raster should be elevation. Click OK, and these are optional. We don't need to use for this exercise. Click run. Right click and add to display. Where is the cities? Let me put this on top of here. You see, the distance layer shows the distance from the city center, from city center to outward to all other directions. Okay, how do I know? For example, click close to city center, we will have a lower number, for example 906 meters. Click somewhere further, you see we are getting larger numbers, so it makes sense. Okay, now I need let's go back to ModelBuilder again, and I'm gonna use conditional tool again and connect this, double click it where value is greater than or equal to, right? Because you see, suitable area is greater than or equal to 1000 meters, 1 kilometer, 1000 meters. 1000, because our data's unit is meters, so I have to put 1000. Input true raster 1, input false raster 0, and this is the criteria 4. Criteria 4. Let's run it. And right click to display. Let's go map. Yes. You see, almost all these areas are suitable because they are far enough from the city centers. Only the areas that have less than 1 kilometer distance from city centers are unsuitable. Anyway, let me uncheck this again, go back to model. Now we have to overlay it. How can we do it? We can do it just using the raster calculator. Just multiply all criteria, right? All criterions. Criteria 1, criteria 2, criteria 3, and criteria 4. Because each one has value of 1 and 0. So when I multiply these 4 data, then we are going to get 1 and 0 again. And 1 will show the areas that contribute all 4 conditions. Let me connect it. Map algebra expression. Second one. Let me connect third one. Let me connect. Double click it. First one is criteria 1. Multiply criteria 2, multiply criteria 3, multiply criteria 4. Again, why we are multiplying it? Because when we multiply 1 times 1 times 1 times 1 is equal to 1. That means we are finding all areas that comply with all 4 criterions. Okay, and let me name it suitable. Run it. Right click, add to display. Yes, as you see, it's very few areas only comply with or satisfy those 4 criteria. Now we have to clip it, right? Clip this raster. So I will use extract by mask tool to clip clip data using a basin or boundary layer. Click, connect, input raster, double click it, and input raster. Okay, and this is the basin, right? Basin is our boundary layer. Just click OK, click run. Right click, add to display. Okay, now we clipped it. Now we have to, because as you look at it here, note that only eligible sites larger than 10 hectares should be considered. So I have to convert this. I mean, it's better that if I convert this to polygon so that I can use patches, right? And then I can select only patches that have area larger than 10 hectares. Okay, raster to polygon tool. Where is it? Raster to polygon. Let's connect it. Double click it. Field value, and let's rename it suitable polygon. Okay, here is the most important part of this. Don't click this create multi-part features, because if you click it, then the output will have only one row, which we don't want. What we want is multiple rows, right? Multiple patches, and then we can select those patches that have area of at least 10 hectares. By default, it's unchecked, so you don't have to do anything. Just click OK and run. Right click, add to display. Okay, now it's polygon. right click. Let's look at the attribute table. Let me bigger. You see, now we have shape area. What is shape area? Shape area tells us that each row has how many square meters the area covers, right? Let me right click, sort descending. Right now it's sorting from larger to lower, okay? The areas for each row, each patches. Okay, let's go back to Model Builder again. Now because when you look at again this, sorry, let me, you see we have shape area, but the unit is square meter, and I can create another, I can add another column or field here for the hectare, area hectare column, for example, and then I can select patches or areas that have larger than 10 hectares. So I do that using the calculate field tool. Is it here? Yes, calculate field. I'm going to add a new field within this layer, okay? Click and input table. And the field name, I'm going to name it area underscore HA, means hectare. And the field type is going to be double, of course. And how can we convert square meter to hectare? Just click this double shape area. This shape area have values in square meters. So if you just divide by 10,000, it's going to convert it to hectares, okay? Click OK. Run. Okay, now just right click again the attribute table. We are going to see the new field, new column. Right now it's hectares, unit is hectares, so we can just select the areas that have at least 10 hectares, but don't select this one because this is the boundary. How do I know? Because it's huge, and also grid code is 0. What we need is grid code 1. It should be 1, right? Anyway, let's go back to model again. Now I can use select tool. Connected, input features, double click it, and where area hectare is greater than or equal to 10, because this field right, we need areas that have at least 10 hectares. Add another clause, and the grid code is equal to 1, right? Because I don't I don't want the grid code 0, which is boundary, so I don't need that. And the name, output feature class, suitable final. Let's rename it suitable final. Let's run it. Okay. Go back to here. Right click, attribute table. You see? Area, hectare, 10. Oh, something is wrong, I guess. Just a second. Oh, this one. Sorry, that's the old one. Attribute table. Let me, yeah. No, it makes sense. You see, area hectare is this one. Right click, sort descending. Yeah. 61 hectares, 40, 18, 16, 12, 11. You see, only, it has only 6 rows. Right click, zoom to layer. This and this here. I don't know if you can see it, but see this and here. Right click, zoom to layer, right click, selection, oh sorry, symbology. Instead of single symbol, use unique values. Click this, add all values. Now we can see it clearly, right? These are the patches. These are the areas, most suitable or most optimal areas for solar power plant. Okay, that's fine. Let's go back to our model. Okay, we are done with the model, but let me show you like this. When we go to model, for example here, when you just double click it, you see no parameters. So the best way is to use parameters to run the model. And for that, because just click, for example, for each input layer, just first one is elevation. Click, right click, click parameter, and cities, click, this is also input, right click, parameters. Okay, and then basin. Click, parameter. And for the output also click, right click, parameter, and click save. Click save. Now go back and double click again this model. Now you see, now everyone, each user can use their own input data. For elevation, you can use your own elevation, own cities, own boundary layer or basin, and you can name it the output, whatever this one, wherever you can save it wherever you want. All right. Okay. I don't know. I hope you liked. I hope you liked this tutorial. If you found this tutorial helpful, please hit that like button and subscribe for more tutorials. Thank you so much for watching, and I'll see you in the next video.